The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I'm going to take 1 minute before we start and just make sure everyone is here. Just to remind everyone, this webinar will be recorded and the presentation will be made available on demand later. Okay, so let's get started. Welcome, everyone. I am Jeff Spalletta, and I'm here today with Tade, who is part of our partnership to bring you the Sensu Ansible collection. I just want to introduce his company. They are XLab Steampunk, and they've been pretty instrumental in making sure that we brought you a pretty high quality Ansible collection as part of the Sensu Go offerings. And here is today right here leading the pack. So I want to make sure I got that introduction out of the way. Like I said, I'm Jeff Spalletta and I work for Sensu. And during this webinar, what we're going to do is we're going to talk a little bit about what Sensu is and how it works as a monitoring tool. We're going to also try to convince you that there's a difference between monitoring as code and infrastructure as code, and also introduce you to how to make use of the Sensu Go Ansible collection to deploy Sensu and to manage the monitoring resources as part of your Ansible playbooks. And at the very end, I'm going to put it all together. I'm going to show you a really interesting auto-remediation workflow where you couple Sensu and Ansible Tower together so you can have some self-healing infrastructure. So first things first, what is Sensu? So Sensu is an observability pipeline that basically works on legacy data center workloads all the way into container workloads using an agent paradigm. So in the cloud, you'd run up something like a sidecar in a Kubernetes container pod, and then in your infrastructure, you would run agents to basically run service checks to check your network gear or make sure your services are running, or just hardware monitoring. So what's really useful about Sensu is it allows you to basically reuse existing tools. It's sort of I like to think of it as sort of a combination design between Nagios and Kubernetes and how it's all laid together. We really make use of the service check concept that everyone familiar with Nagios is used to, but we also move forward and treat metrics as a first-class citizen too in terms of the data, and we can flow metrics through the system into a time series database of your choice, as well as handling alerting into services or calling in the tower and doing auto-remediation. So there are a couple of really good use cases, right? You're basically eliminating data silos, so you can have you can actually choose a breadth of different outbound data sinks, data lakes, and the like. You can also fill gaps in your tooling so that you can actually bring together metrics, logging, tracing in through the same pipeline, and then distribute them out how you need to, depending on how large your organization is and what different teams need for tooling. And like I said, there's a great thing I'm going to get to in terms of self-healing with things like Tower or Rundeck. So here's just sort of a depiction of what it looks like when you're running a Sensu architecture. There's a backend service that basically acts to schedule your checks. We make use of a flexible subscription model. So the idea is that they are loosely coupled so that you can have logically defined subscriptions that represent services deployed somewhere in your infrastructure, and then agents would subscribe to those. So it's a loose coupling between the monitoring you're doing and where you need to do it. We also have things like RBAC, and it's a completely REST-based API, and And like I said, a lot of the pattern there is borrowed heavily from how Kubernetes structures things in terms of namespaces and being able to have cluster-wide control versus individual resource control. And more importantly, it's declarative for all the resources. So it's YAML files or JSON. So the idea is that you can take all of what you're used to with infrastructure as code and move it into your monitoring workloads. So you're getting the same sort of declarative code that you can store and get and version as you need as a collection of resources. But one thing I want to point out is one of the really useful features with Sensu in making that work, monitoring as code work, is the idea of these shareable assets. They're very much in the spirit of modules, like from an Ansible perspective, where except that these are binaries that you can thinly package that you can specify support specific monitoring checks that you need. So if you need to run a specific command, you don't have to pre-provision it onto the agent. You can actually download that just in time. Or if you need a specific filter, you don't have to pre-provision that JavaScript filter in the transform step here in the back end before. You can actually tell your monitoring as code collection to find these assets and use them, and they will be downloaded if they're needed, if they're not already present. So monitoring and automation, right? Like Ansible is all about automation. And so what's the difference? Why do I want to talk about monitoring as code? The big difference is monitoring is what you need to be doing nearly continuously, right? To provide actual information about failure to defects. Whereas automation is sort of what you do if you need to take action on something. It's not a continuous operation. It's if something's changed or something has fallen over, you then automate those tasks, so you're saving humans time, right? And so what I like to think about is Sensu is monitoring as code, because you're able to declare these monitoring workloads in the same sort of way that you would declare infrastructure as code with Ansible, right? But it's sort of a parallel track because they're serving different purposes. And so I'm getting ready to hand off to my partner here, but I just want to point out that part of this Sensu Go paradigm is we really want to make it work with the config management systems that people are using, so that we can easily deploy Sensu Go in the wild, so you can spin up a backend cluster and put your agents into the infrastructure as you need as part of your provisioning. And then you let the monitoring as code aspect of Sensu take over from there, so you can update that monitoring without having to re-provision your existing infrastructure just to make a small monitoring change. So I just want to go over real quick the highlights. I'm really excited about the Ansible collection stuff and the work that today has put in to get our official Sensu Go Ansible collection up and running. Ansible collections are really great because they allow us to, as a vendor, be able to put Ansible modules out there that support our product at the same scale that we're making development changes in the product itself. So it's not tied to Ansible's release cycle anymore. We're also able to have versioned versions of the modules or the collection, so that you can get the one you need that matches the version of Sensu that you're running. So I think with that, if today is ready, I think we want today to take it over and show you a demonstration of what you can do with the Sensu Go collection. Are you ready there, sir?
I think I am. So I'm just taking over the control, and I think I did it. So hello, my name is Tadej, as Jeff already told you. So what I'll show you today is how to set up a minimal Sensu Go cluster. So what we'll install is a backend on one virtual machine, install agents on other two virtual machines, and establish a secure communication between those machines, because we will be passing some sensitive information from the backend to the agent. So all of you that know Ansible, you're probably familiar with the term inventory. So this is the first important part of the Ansible. This is basically the list of resources that you want to manage using Ansible. So if you look at our inventory file, the two important things are that we defined two groups. One group is a backend, and the second group is a agents group. So this is how we can group together similar hosts, so things that perform the similar operation. So in the backends group, you have a single backend, and the information in these two variables tells Ansible how to connect to our virtual machines. And the same thing holds for the agents. So we have two agents, and the information about the Ansible needs to establish an SSH communication with the virtual machine. So inventory being out of the way, we also need a way to specify what state we want a resource to be in. And this is what Ansible Playbook is for. So if I just open a backend playbook, or the backend that we'll use to set up the backend. So this is what I like to call human readable and machine executable description of the desired state. So even if you never used Ansible before, reading through the YAML file, you probably get the general idea what we'll do. So as you can see, there are two things that we'll perform here. The first one is we'll set some environment variables on the backend, and we'll store some sensitive information in there. So our sensitive information is this part. So the value is here. And then we'll use the Sensu Go's built-in secrets management to bring that value securely over to the agent and use it in a chat. The other important part is the actual installation of the backend. So this is the part that will actually install and configure the Sensu Go backend. So what we'll use for installation is the backend Ansible role, and we can parameterize it using the variables specified here. So we can specify what version to install, how to initialize the database, and how to set up the secure communication, or parts that we need to secure the communication between backend and agents. So one interesting thing is here, for example, this shows you how you can keep your sensitive information out of the playbook. So this playbook is completely safe to commit into your version revision system, because there are no sensitive information in it. We instead store the Sensu user and Sensu password that we want to use to initialize the database in the environment variables, and then use the lookup plugin to search for those variables. So for example, these are the variables that I defined on my local machine that Ansible will use to fetch the values for the cluster admin username and password. Yeah. So this Sensu password will go to admin password, and Sensu user will go to admin. Another important thing is the TLS stuff here. So basically, setting up a secure communication is pain in the ass, so to say. Because you need to generate certificates, place the certificates on all of the machines that use them, and then configure your software to use those certificates. Ansible collection cannot help you with the first task, so you still need to generate certificates on your own. So this is something that we cannot help you with. But placing the certificates at the right location and configuring the software is something that Ansible can do. So in our case, you can see all we did is point to certain files and said, these are the things that backend should use. And the Ansible role will copy them over to the backend and configure the backend to use them. And this last part is actually not part of the playbook. This is just for lazy today to copy over the command, how to execute the playbook. And as you can see, although the playbook is relatively short, what is Ansible actually doing is way more complex. So we are adding repositories to the distribution here, installing components, for example, and copying over TLS files, so certificates, for that now configuring, and then also initializing backend using the username and password that is specified. So, and it took us, I think, no more than half a minute, and if everything went as expected, yeah, we have a Sensu Go backend running, and I can use my very secure credentials to log into the dashboard. So as of right now, we have nothing yet to report because we did not prepare our agent yet. So let's open our agent playbook and go over that real quickly. So here we see basically the same stuff as before. The only thing that changes the basically hosts parameter. So previously we were executing the playbook against the backend hosts, and now we are executing this playbook against the agents. So we want to install Sensu Go on agent machine. Then another thing that is different is the role name, because we're installing agent, and all other thing is basically the same. So we specify a version. We need to copy over some files to make sure TLS is working. What we did not see before is the configuration. In the backend use case, we just used the default configuration. We did not change anything. But in the case of the agent, we need to at least specify a name so we know how to reference this agent when we configure it lately via the API. And another important thing is we need to specify where the backend lives. And instead of just hard coding the address of the backend into our playbook, we basically used Ansible to fetch this information from the inventory file. So if I open the inventory file, this hostwars backend Ansible host basically means find the backend host and fetch this information from the file. So this allows us to reuse the information we already have stored in other Ansible files. And again, this last line, not really part of the playbook, just the convenience for the presenter here. So as before, Ansible is doing all the things it needs to do to get the agent installed. But one thing we do see here is that the installation is done concurrently on both virtual machines. So we are installing things on agent 1 and the agent 0 at the same time. And as we can see again, here is the nasty part, or the part that is tedious, usually copying over the files, done nearly instantaneously and without any effort from our side. Okay, so if you now switch to our default namespace and check for entities, you can see we have our agent 0 and agent 1 entities ready for us here. And all that is left for us to do is now to actually configure something to observe. So basically to establish an observability pipeline, as Jeff said. So again, we can also do this from Ansible. And again, even if you never saw the playbook before, you can probably see what will happen. But before I go over what will happen, I'll just say that this thing is a bit special. This is something that you can only do if you're using Sensu Go version 6. Before that, Sensu treated agents and agent entities as one thing, so you had to configure the agent entities in the configuration file for the agent. So basically, this information that I have stored here, would need to be placed into the agent configuration file. As of Sensu Go 6, things are much more dynamic, so we can actually update the subscription that Jeff already talked about on the fly. So we don't even need to restart the agent. We just update the things via the API, and the agent will update itself as required. Okay, so this is basically the thing that we say, please, agent 0, listen to the demo subscription and do whatever comes from that pipe. And in order to set up this, as I said, we need to bring some secret or confident information to the check. We need to set some resources on the backend. So the first thing we need is we need to make sure that our secrets provider is ready. Then we need to register a secret that will fetch its value from my secret. environment variable on the backend, and then we create a simple check that just echoes our secret. So here goes the security, and uses the my secret as a source. This was so complex that I decided I'll draw it how things work. So basically, when we set up the backend, we defined my secret with the value is here. Then now we'll create a secret resource that references the environment, and when the check will be executed, the my secret will be placed into the secret environment. So this part is important. The secret is transferred from the backend to the agent in a secure manner because we secured the communication between those two. And as before, we just copy this over and be done with it. Oh, or maybe not. Okay, so what you see here is the Ansible complaint that we are missing the secrets provider environment, module. So to see what's going on, we'll go to the Sensu Ansible collection documentation and search for this module. And the documentation says the module should be there. But what we notice here is that we need a version 1.6.0 at least. So this was added quite recently. So let us see Galaxy collection list. Let us see what we have installed locally. So here's the problem. Our Sensu collection is too old to support the things we want to do. And this is what Jeff talked about. If we were still using the monolithic Ansible model, we would be forced to wait for the Ansible to release and update. But in our case, we can just update the Sensu Ansible collection and continue with our work. So we go to the Sensu Galaxy page because we have an installation command here. So I can copy it over. Paste this, and we need to add the force flag to the installation command. Otherwise, Ansible will refuse to replace the older version. As Jeff said before, we can also use a version specifier if you want to. So for example, this will install the version 1.6.0 instead of 1.6.1. But for our case, things will do just nicely. So now we can rerun our config playbook, and you can see now the things worked as expected. And if you take a last look at our UI, we can see that our agent actually gained a demo subscription. And if we go to the events and list all of the events, by default, we only see failures here. We can see that agent 0 actually executed a secret check, and the values here did make it securely from the backend to the agent. So that is basically all from my side. I hope you learned something. I hope you see the value of a high-quality Ansible collection because it allows you to succinctly describe your infrastructure and then let the Ansible deal with the intricacies of setting things up. So that being said, I'll just
actually, if you stay on that slide, I'd like to point out a couple of things since you made excellent use of the mutual TLS to broadcast secrets to agents. I want to point out that the environment provider that Sensu has isn't the only provider. We actually support HashiCorp Vault as a secrets provider as well. So using the environment provider is a great way if you are prototyping in a development environment and you want to get the secret definition right. But when you move into production, you can just switch over to the Vagrant provider and I'm sorry, to the HashiCorp Vault provider, and it'll just work. So it allows you to prototype with these environment variables that are set in the backend environment, and then still move forward into a more secure setting. It's really interesting. The environment provider works really well also with Kubernetes concept of environment secrets. So when you're setting up something like a Sensu backend cluster in as part of a pod, right? It'll work sort of seamlessly with that Kubernetes approach. So I just wanted to point that out because it's pretty flexible, and we require the mutual TLS for the secret handoff to happen from the back end to the agent to make sure that it really is a secure connection. You're not accidentally sending secrets over to an agent that is using a insecure communication method. So thanks a lot for that. That's a good place to hand off. Let's see if I can actually reshare my screen now. It's always fun. Yeah, there we go. I think I am good. Can you see my screen?
Yes, we can, Jeff. You can go
Great.
on.
Thanks a lot. Okay, so now that we've had an overview of how the Sensu Go collection works, I think it's important to sort of drill into the key concepts I'm going to show you in the demo videos. I'm not going to live demo like he just did. I have some pre-recorded, some canned content because I've learned my lesson about YOLOing demos. So key concepts here about what I think of in terms of monitoring as code, the way Sensu does it. We have these entities, which are a resource in Sensu that are agents like you just saw, but we also have a concept of a proxy agent, which will actually perform tasks on behalf of another machine. This is a great way to service things like network gear, where you want to monitor the network gear, make sure it's operating correctly, or you can actually write service checks that run on an agent on behalf of this proxy that's named differently, and therefore the data flows through Sensu under that proxy entity's name. You just saw he did a very quick echo check. These are things, checks are scheduled, and that's sort of the main component of what our monitoring workloads look like. If anyone is familiar with Nagios, you will be quite familiar with this concept, right? Except we put a slightly different spin on it. We sort of flip it so that the agents communicate back to the backend and ask what checks they're going to be running based on the subscriptions they've asked for. The observability pipelines, we haven't shown that yet, but it's once you have that event, as you saw on the dashboard, coming in, you want to process it somehow. You need to filter it and make sure you're not getting alert fatigue. You need to transform it if you need to throw it into a data lake or something. And then you want to process it by some sort of external service, something like Ansible Tower or PagerDuty if you're doing some sort of alerting. And like I said, this all is based on these event constructs, which is a Sensu data type that records sort of some minimum history about what's happened with the like last 20 runs of that check, which entity ran the check, information about the entity, sort of facts gathering so that you can make use of that and decide what you need to do based on that information. Subscriptions really sort of how we tie it all together, so you can have a subscription that's associated, say, with a Postgres service or an Nginx service, and then have all the checks part of that, and have agents subscribe to those subscriptions without having to tell the agent exactly all 300 checks it may need to be running, right? And then the assets, which he didn't use in that demo, but I will be using, is what really makes this sort of monitoring as code, so you can actually have some great flexibility in terms of spinning up additional monitoring without having to re-provision the host that are running the checks. So let me show you. Here is, I'm gonna be building in this demo a real workload just to do an Nginx service and monitor it real quick and make sure it's up and running. So, whoops, there it is. Let me start the video. So this is going to look very familiar, right? Because I have to get things spun up. So I'm going to have a set of Ansible playbooks that just create a backend and a single agent real quickly. But I'm also going to set up a real check using the Sensu Cuddle command line feature, I'm gonna create the resources outside of Ansible to show you that can be done that way. Then I'm gonna go back and show that you can use the collection to build the same thing. So here is a version of what you just saw. I'm basically going to install the backend, and I'm going to set the username. I'm doing it a slightly different way, and then I'm taking the password and admin user from a variables file. So like we just saw running it, we're going to get the backend up and running. And now we're going to provision the agent so that it will communicate. And in this case, I'm actually using the non-default namespace. So I'm able to use the Ansible collection to define a new namespace just for this webinar. And I'm saving it as a variable. So, but the idea is I'm using the collection here to interact with the Sensu API to set up a new namespace. So namespaces are very similar to the Kubernetes namespace concept, where we envision it as different teams can make use of a standard Sensu backend and be able to own their monitoring that goes side by side with their application, right? So if they're spinning up environments or hosts that they need to do development, they can also monitor that, or in production, they can monitor that no matter where those things are, and keep up with it inside Sensu and make sure that the monitoring is auditable. That's one great thing about the role-based access in Sensu, is you can actually have just a role that's just used for auditing, so you don't have to have you don't have to give someone access to write into a namespace, but you can at least review and make sure that you have the coverage you need on a regular basis. So here we are. I'm just setting up the real quick. I think we've all seen this Nginx setup role. It's just going to set up an Nginx service on the same host that the agent's running on. And once that's up and running, we're also going to set up the CLI client so that I can actually interact and show you what's going on with the Sensu resources. And the CLI client is just like the web UI that you saw in the previous demo. This is just the CLI instead. They're both interacting with the same REST API. It's just that it's a different interface, right? So here I'm configuring it so it basically holds on to the admin password so I can make use of Sensu Cuddle repeatedly. And this is the CLI view. Here's a entity list. I have one. It has a setup with an Nginx subscription already. They also come up with a host-specific subscription so that you can use that if you need to just interact with a single host. I'm going to show you that there's no checks defined yet. So I'm going to actually use the declarative YAML file to define a check command here. It's called check HTTP, and then it's going to run a little Ruby script that's a Sensu plugin to run, basically check and make sure that Nginx service is up and running, and it's going to be using runtime assets to provide that command, and then it has some handlers defined, including Tower, to do something if the service is down. So I've just added it to the Sensu state, and it's set up initially in a publish false. So the idea is that you can define checks, but they're not running yet on an interval. They're just sitting there. And now I'm going to actually execute this so that it runs just once, because I'm sort of in the testing mode, right? So you don't have to make a check live right away. You can actually test it before you actually put it into service. So here I actually have an error because I couldn't find the check command that it wanted, because I didn't actually add the assets yet. I've said use these assets, but they aren't there. And what's great about the assets is we actually have an asset index called Bonsai, Sensu's Bonsai, which you can search for assets. It's very much like Ansible Galaxy, but you can also define them manually. And here's a situation where this is the resource file, which is effectively manually built instead of being pulled automatically using the Bonsai integration in Sensu Cuddle. But what's important is that these asset packages are, these resource definitions really are just a SHA sum and a URL and some filter rules to say only use this tarball, this package, if it matches these particular filter requirements. That way you can have binaries for a specific version of RHEL or CentOS or Windows or wherever the agents, the Sensu agents run, and you can have different versions or different binaries to do the same task, and they will, the filtering rules and the asset definition will pick the right one based on the host information associated with where the agent's running. And we use these assets not just for checks, but you also use them to support the handlers, and I'll show that as well when I work with the tower information. And then filters, everything part of that observability pipeline, you can actually supplement with an asset that's pulled in a just-in-time fashion. And you can store these locally in your own infrastructure. You don't have to use the publicly available ones. So that way you can put a lot of your business logic, a lot of your reusable tools that you want to do for your checks for your homegrown services or whatever in an asset and make them available. And you don't have to complicate your provisioning for your host up front. So that way, for people who are used to Nagios, it's sort of the opposite, right? Because Nagios, you had to spend a lot of time making sure that all the checks you wanted were pre-provisioned before you could ask to do a remote plugin execution. And this way gives you way more flexibility, especially as you start dealing with containerized workloads, where you don't necessarily want to bake those things or take them offline to increase your monitoring, especially during an event where you need to add monitoring because something's going wrong and you haven't caught the right thing to check yet. So here we go. Did the service setup where I defined the services in the Ansible collection instead of doing it just in Sensu Cuddle. Now I'm actually using the collection, and I'm now going to set these resources up in such a way that, yeah, I want to actually do all of this inside Ansible and use the collection. And I'm like, I want to set up an NTP check, and I want to make sure that it's using this additional runtime asset that we have called the monitoring plugins, which are just builds of the monitoring plugins that spun off from the Nagios plugins. We also have the Nginx check here again, where we're using the Sensu plugin assets and the Sensu Ruby runtime. So we actually have a Ruby environment that we didn't have to pre-provision the Ruby environment that matches what that plugin needs. And so all of those resources can be handled as part of the Ansible collection. If you want to keep everything inside of Ansible playbooks, you don't want to use the Sensu Cuddle approach where you're creating these resources from YAML files. So I ran the resource setup playbooks, right? I changed the entity subscriptions to match what each of these checks needs, and now these checks are actually in a published state, so they're now running on an interval now. They're not, they don't need to be executed individually. I now have an additional asset because I defined 3 in that playbook, so I have all the assets there I need for this CentOS 7 environment. And like I said, these assets are stripped down because I'm only working with CentOS 7 environment. I want to make it easier to read. And now if you look at the event list, because these checks are running, I now have the Nginx check is running now, and the NTP check is running. And because the the runtime assets are there, these commands exist on the agent without me having to install any additional RPM packages or binaries as part of the provisioning that was originally done. And there you go. That is setting up a monitoring workflow that actually works with a service. And that's an example of, or part of example, sort of what you can do with this monitoring as code concept. Let me move on. So what you can do after that is that you can actually now close the loop, right? So we have Ansible sort of providing the ability to build these resources in Sensu, and when Sensu is now defining the schedule and when these checks are running and producing events, now we want to do something with those events if there's a problem, right? So what we can do is we actually have an Ansible Tower handler for Sensu that you can trigger job templates in Tower based on certain conditions. So if, for example, that Nginx service goes down and stays down for 3 occurrences, I want to run a remediation playbook, right? And try to get that service back up, doing tasks that I know would fix the problem, right? But you don't want to do that remediation all the time. You want to just do that remediation if it works, and then stop doing that and then escalate to a human being. And with Sensu's alerting mechanisms, it's exactly what you can do, where on the 3rd occurrence, you can run a playbook, and then after it's failed a couple of more times, you can alert. And this is part of that observability pipeline where you can filter on the alerts and really drop that alert fatigue, so that when the humans finally are alerted, it is something that they haven't automated in terms of a remediation. So I like to think of it as like, you got agentless infrastructure provisioning in my agent monitoring. You got agent monitoring in my agentless infrastructure provisioning. Like, they actually are better together, right? It is the Reese's cup of technology, where you have these agents providing somewhat continuous monitoring, and then you're able to move into automation where you have complicated or reasonably complicated or tedious tasking, right, that you can then do to remediate the situation and clear up the monitoring alerts. And once you build these workflows, it really helps to reduce alert fatigue. Like, the more you can automate away remediation, the more you can do these tasks that you know will at least temporarily fix a problem. You can then have a human being wake up at a reasonable hour and then see that the playbook ran, and then go in and see if they need to address something more significant with their brain power once they've had a cup of coffee. So I want to show you what that looks like when we put it together real quick. This is going to be, I'm not going to go into deep details here. We actually have a webinar that just talks about the Tower integration, but I wanted to show you it in action without getting into all the detail. So this is a very similar setup. The check names are a little different, but the idea here is that we're going to have a check, not the metrics check. We're going to have this Nginx check again, right? But more importantly, and I'm going to pause this right here. The important thing here is that because the checks are allowed to be annotated with additional information, this annotation specifies under what conditions the Ansible Tower handler that's going to process the resulting event fires. So in this case, on the 3rd occurrence, if it's a severity of 1 or 2, so a non-zero severity, it's going to ask Tower to run this server stand-up template using the webinar inventory, right? And only on the 3rd occurrence of a failure. That way, I'm only trying to run this once, and I'm not going to keep asking Tower to run the same remediation, because that's just a brick wall, right? So you don't want to keep doing that if it's not working. And then on the 6th occurrence of an all clear, or everything's working again, it's going to run a different template that basically is saying that everything's back to normal. And we're able to encode this into the check itself, so that way it really gives you the ability to empower your teams who need to self-service their monitoring to specify with great granularity what their remediation strategy is and what their alerting strategy is, so that you aren't just throwing everything to a chat ops or to an email or PagerDuty. You can escalate into that, but you don't have to do it for every single time something goes wrong. So here I am back in the dashboard, the Sensu dashboard. As you see, there's the check exists. I'm going to actually go in and make sure that the starting the Nginx service, so it's leaving the failed state, and it's going to go back into an OK state, and it's running on like a 10-second interval, pretty aggressively. And I'm going to check the passing. It's now passing, and now I'm going to use this little timeline visual that we provide in the dashboard to indicate that you're watching it as each time it comes in, there were failures, and now there's going to be multiple successes. And once it reaches 6 successes in a row, the Ansible tower all clear job should be running. These were previous jobs when it was in a failed state. So the current is at 4, current is at 5, the job template hasn't run yet, and as soon as we get to a current to 6, as specified in that annotation in the check, it's going to run the everything's great. There we go. The all good here job template is running as specified by the Ansible Tower handler. And now I'm going to stop the Nginx service and show you that the remediation handler that runs on 3 failed checks will run and actually remediate and bring the service back up. So occurrence 2, and on the 3rd occurrence, and all it does is, kick the service in the head and restart it. It's a very simple remediation. But hopefully it gives you an idea of what you can do here, because obviously, as your remediation patterns, what you need to check, it's more complicated. You can extend your remediation playbooks or layer them so that you try one thing, and if that's not working, you try something else, right? Especially if there's a networking problem, or you don't know if it's the application or the network, you may have to do that kind of escalation. And Sensu allows you to do that pretty easily. And more importantly, you can, because this is all defined in the check, you can change this on the fly during an incident if you need to, or add additional checks if you're trying to diagnose an ongoing event that you don't have remediation for yet. So that is an example of self-healing remediation. Here's just a recap of what we talked about today. Sensu provides some declarative resources managed by an API that you can interact with, either with the Sensu Cuddle CLI or with the Ansible Sensu Go collection to manage these resources, depending on what workflow works best for you. The subscriptions are pretty important for how this works, because it allows you to loosely couple service monitoring, so the collection of monitoring that you need to do to think that you've covered the service or the infrastructure, separate from where that workloads run, so that in the case of services, right, you have an agent sitting inside the network and this agent sitting outside the network to make sure that both inbound and outbound are working correctly. So assets let you provide updated monitoring workflows in a just-in-time manner, so you don't have to do heavy pre-provisioning of the host to make sure that they have all the monitoring that they could ever possibly need before you need it. This way you can be much more dynamic with it and separate your infrastructure from your monitoring as code because they really are doing two different jobs, right? And then the last thing you saw an example of using Sensu and Ansible Tower together to get some self-healing infrastructure workflows where you're using the monitoring to activate your infrastructure as code. So next steps that you can do with Sensu is that we do have an on-demand webinar now on how to use the Ansible Tower integration. So please, if you want to get see specifics on how that works in detail, please go watch that webinar. You can also join our Sensu community and ask us questions about anything Sensu Go plus Ansible related, where if you're trying to tie things together, we're there to help you figure out how to do it. And if you need a one-on-one demo of something Sensu related, please feel free to reach out and contact us. We're happy to give you a deep dive into any specific needs you need there. Also, a shout out to my friends at XLab Steampunk. They did a great webinar recently on how to test Ansible collections, which is a really important thing if you're thinking about building your own collection. They also have this on demand now, so if you want to go and watch that and learn how to better test your collection, this is the webinar to see. So thanks everybody for coming. I think that's it. And I'm going to sign off now. Thanks today for helping out with this, and I think that's it. Thanks everybody.